Please subscribe, like, and share. Today we'll talk about carburetors. I've said for many years, why is it that one guy has the same basic combination and the other guy is similar but somehow is head and shoulders above everybody else? It's a selection of parts. You can run both an 850 carburetor or a 750 on the street or racetrack, and somehow, why is this other guy's car, everything was as far as possible even, pulls a lot stronger? Well, one of those is the choice of carburetors, be it an annular discharge, straight leg, or a down leg booster. It makes a difference. Now, if you have a 750 with an annular discharge, you will beat that other guy, run the same 750, but it's got a straight leg or a down leg booster. And here's the difference between those two. Here you're looking at a Holley 750. There's a straight leg booster. All right. And I wish I had a copy of an annular discharge, but I will post this picture for annular discharge right there. Now, when you have the same throttle plate Venturi diameter and you go with a down leg booster, you can see it right there. It goes down. You pick up about 30 CFM. Okay, so when you look at the throttle diameter, Venturi diameter, and one is a straight leg booster, choose this one here, a down leg booster. You'll get a little bit more power. Okay? But that said, it will not compare to a Dominator, or not a Dominator, but an annular discharge Venturi. Okay? You don't see the difference. Both of them 750. Now that you saw it, every time you have the down leg booster, it picks up in flow. Carburetors don't suck fuel and air. They never do. It's an absence of pressure is the correct terminology. When somebody tells you they're an induction expert and they tell you their intake port sucks fuel and air, I'd stay away from that. That is not the proper definition. If you can't have the proper definition, how can explain it? How can they explain it correctly? I'll show you a little bit of a why there's no suction. This little experiment, and see what you think. This is a perfect example of what I'm trying to show, that there's no such thing as suction. And the carburetor runs under the same principle, okay? Or the intake port or the cylinder. Atmospheric pressure has weight around everything, and around us the air has weight. Now when I do this, all right, there's no air pressure or atmospheric pressure acting on top of this water bottle. But the difference is, when I let go of this, atmospheric pressure goes in here, you'll see it, put pressure on the top and push the water down, then it'll stop again because there's no more atmospheric pressure. Another gulp, air again will come in and go on top, and then push down again a certain amount, and then the next cycle it needs to have atmospheric pressure, another gulp, go in there, and then lower down. If you can slow motion this, and I'll try, and we'll see. See that? It's going like this, okay, because it's trying to breathe. It's trying to take an atmospheric pressure to push on the top. You'll see it right there, okay? Well, let me take this off. Let me take this off even better so that you can see it even more clearly. Okay? Now, here we go. You'll see the breathing. There it goes, breathing. Atmospheric pressure goes on top and lowers down. Now, that's atmospheric pressure. Same thing on a cylinder. Same thing on an engine when it's trying to run. Now, I cut a hole right there to allow atmospheric pressure to happen, okay? And now we have direct atmospheric pressure acting on this bottle, all right? And look how fast it'll discharge. You guys see that? Let me take this off here. Okay? Atmospheric pressure acted on top immediately, as opposed to the other one where it's trying to breathe. That is how an engine functions. Clear? Whereas this one here, atmospheric pressure has to act on it and has to breathe in order for atmospheric pressure to push down on it. So it's really no suction. Same thing with the intake port. All right, look at this. It's breathing, 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 breathing. All right. So I think that's clear, you guys. Let me just, I just wanted to make that example. Now they just seen that atmospheric pressure is the one that pushes down on a Venturi or a port. This shows it right there. Without atmospheric pressure putting weight on top on the descending piston, which creates more volume, creates a low pressure situation, or what they call suction or vacuum. Okay, we'll use that for the sake of this thing. But anyway, this explained it quite clearly. All right. Now, on an annular discharge, at low engine speeds, what it does, it's able to effectively atomize the fuel or mystify the fuel compared to a down leg booster or a straight leg booster. Very important. Okay, because at low engine speeds, it's got a weak signal. The annular discharge Venturi is most effective at that range. And what actually happens there, especially you guys running nitrous oxide or boosted, every time we do a gear change is when the engine wants to detonate. And the annular discharge carburetor or annular discharge Venturi carburetor, since it's able to pull the signal more effectively, tends to run a little on the richer side. Saves your engine. Especially if you have a annular discharge, it's mystified, it's able to take the turn, you know, on a 4-barrel intake manifold, typical V8. The end cylinders, all right, it's farther out. What happens here? If it's finally mystified, the mystified fuel molecules can take and turn with the air column. If it's a solid, or not really solid, but it's in raindrop form, not mystified, it will want to keep going straight. It cannot turn with the air column. So anytime the molecules are finally dispersed or atomized, it's able to take the turn. Now you got your advantage. Now, annular discharge carburetors tend to flow about 60-65 CFM less than a comparable straight leg or down leg booster. That's significant. But the power is still better because of the situated mystified fuel that's easily combustible, especially the low mid-range areas. Even at high RPM, anytime your fuel is mystified, it's a plus. Okay, so there are multiple discharge holes in an annular discharge. Typical dogleg booster is 1. 2, the Venturi, it's got a pull there that I showed earlier. With an annular discharge, there's numerous holes, 6, 8, or maybe 10, depends. Some specialty manufacturers out there that modify these carburetors have a lot of small little holes. You know, there's a point of diminishing returns, but I'm sure it doesn't hurt when you could mystify these things before it gets into the cylinder. Here's the Dominator, right beside each other. That is an annular discharge Venturi right there. All right, and you can tell the difference is on a standard Venturi you have a what I call a casting here, straight across. All right, and it looks like this, like that, and it discharges fuel right underneath that to the hole right there. That is a standard Venturi. There's an annular. There's a bunch of holes around there, 6, 8, or maybe even more. Depends on the amount of mystification you're trying to achieve. And here's the skirted annular discharge Venturi. You can see it right there. All right. It's also very effective, and all it does is to increase the signal to further mystify the fuel as it discharges into the port. Very, very effective. Now you see the difference between the two. All right. Now, since the signal is strong on an annular discharge, the main jet is actually smaller, comparably. All right. But the signal strength is so strong, it pulls the fuel in and keeps you from leaning out. That's a plus. Now, on camshaft with 220 degrees duration and plus, I would recommend you run an annular discharge, okay? Because they tend to be a little sloppy on the bottom end, a little, cami or low speed torque is not really there, especially when you don't have enough RPMs or you don't have enough compression. One thing with carburetor, when it's an oversized or big, you have a Dominator 850, instead of having this mystified fuel, okay, because the signal strength is lessened with a big Venturi or big carburetor or multiple carburetors. And what actually happens is that the fuel condition is not as mystified as it is with a smaller carburetor or combination or less carb, not multiple carbs. It's able to pull that and mystify it through the action of the Venturi. Now, if it's a big camshaft, big intake port, big carburetor, multiple Venturis instead of one Dominator, now you have 2 with 8 barrels instead of 4. You need the compression to help you out, and I talk about this in one of my writings on FB about talking about how compression tend to negate the effects of big camshaft and big carburetors. To touch on that real quick right now is that when you have a big carburetor, so the fuel molecules are not as mystified or more like raindrops, it gets inside the combustion chamber. What actually happens is that if you have 9-to-1, when you ignite this combination at 30 degrees, all right, the flame front starts to burn, okay, but it burns lazy, it burns slow. That's a byproduct of low compression, all right? So when the compression hits it, it goes like this, kind of lazy. Low compression is lazy compression. So it stirs up the fuel and they light up and they went about their own way, okay, producing power. But when you have a big carburetor, big camshaft, big ports and everything, but very high compression, here's what happened. You still have the fuel droplets, just like a fuel injection, same thing with carburetor. The bigger the Venturi, the bigger the injectors, the less mystified the fuel is, okay? It's like a garden hose effect instead of a spray hose. Now here's what happens. Let's say at 30 degrees, you initiate you light it up. Flame front starts like a sphere. It tends to go towards the exhaust valve, towards the intake valve, starts to spread out. Guess what happens? This is 9-to-1. This is 12.5-to-1, 16-to-1. A lot more. What happens here? When the flame front starts at 30 degrees, piston's rapidly descending up, right? It doesn't really light up at TDC. It lights up way before that. But once that fuel inner is expanding and rapidly wants to ignite to an explosion, here comes the piston, smacks it, boom, and propagates the flame front even more. And that's when your quench comes in, right? And it wants to really speed up to an explosion, but it hits the quench part of the combustion chamber. And when it does that, it stops it, but still stirs it up, especially around the exhaust. I mean, the spark plug. When they all come in there, they tend to congregate right there. And it lights up, but it's kind of lazy. But compression goes in there and smacks everything and wakes them up and say, hey, time to get going. The higher the compression, the harder the hit. Like hitting a bat to somebody's head and wake them up and say, hey, time to move. Oh, yes, sir. Same thing. Compression is a bigger bat that stirs up the molecules and blows them up to fine mystified molecules approaching TDC and at TDC and beyond, and completes the combustion. Okay, that's why you're able to take more intake, more Venturi, more carburation, bigger ports with higher compression. You don't have that situation with low compression, 9.5. So when you see somebody with a 9.5 to 1, 10 to 1, and try to run a tunnel ram or a sheet metal intake with that low compression, he's wasting his time. Okay, you need a bigger bat compression to whack that sucker and wake him up. All right, wake up the molecules. Now, that's part of the explanation. I went off topic a little bit, but sometimes I can't help it, and I like to expand on that, because you just can't make a straight statement sometimes without going through, touching a little bit off to the side as part of the explanation, and makes it a little bit clearer. All right. So anyway, that's the Dominator here, an 850. Always run an annular discharge, okay, for all the purposes I just highlighted. Anyway, please like, share, and subscribe to Ben Almeida Racing, and hopefully we keep this going and give you guys good information. All right, thanks a lot, guys. Bye-bye. Please subscribe, like, and share.